Returning real HTML. Let's implement the functionality for returning more than a blank page. Create a new file, hello.html, in the root of your project directory, not in the source directory. You can input any HTML you want. Listing 20-4 shows one possibility. And let's just go with that possibility. That's probably the easiest and fastest. And they want it in the root of the project. So let's say, I want to see the bar. How do I get my bar back? Here we go. So not in source, but with source. So here, new file. I think they called it hello.html. Cancel, paste, golden. And go back to our source. All right, that has been done. And let's read through this HTML real quick. We have the header for that denotes, I believe it's HTML5. An HTML tag, which is mandatory. We have an language set, English. If you don't specify one, I think it just assumes one. We have our header for our HTML. We set the char set to UTF-8. We have a title, which is just be displayed in the bar here. And then we have our body, which is what we're going to actually see when on the page when it renders. Okay, so that's pretty straightforward. This is a minimal HTML5 document with a heading and some text. To return this from the server when a request is received, we'll modify handle request as shown in listing 20-5 to read the HTML file, add it to the response as a body, and send it. So we're importing, I guess that's file system or file server. I do not know. We're importing FS. And then we're going to use that to read to a string the file. And the file we have on our root, so that's to be just found. And then our response is going to format. We're going to have the same header, or well, I guess the same basic response, but instead we're going to put in a body here. So the only thing we're missing is the middle part, which was, what was the middle part again? Scroll up. Headers. We have the first part, which is the HTTP version, status code, and phrase, but we don't have headers. So no headers. Got it. And then we're writing that. Okay. So it hasn't really changed all that much. And then we need to import that. Use a CD FS. And that should be it. Localhost 7878. Hello, hi from Rust. And we have hello here too in the title. All right, cool. Turn that off. We've added a line at the top to bring the standard library's file system module into scope. So FS is file system. The code for reading the content of a file to a string should look familiar. We used it in chapter 12 when we read the content of a file for our I/O project in listing 12-4. This was a very long time ago, but okay. Next, we use format to add the file's content as the body of the success response. Run this code with cargo run and load localhost 7878 in your browser. You should see the HTML rendered, and that is true. And they're just talking about format here earlier. So this is the file system read to string, which takes a location of a file. And then this unwrap takes this an error reading in it. And then we use format to format the response. And then everything else is the same. Write it, flush it. Currently, we're ignoring the request data in buffer and just sending back the content of HTML file unconditionally. That means if you try requesting localhost / something else in your browser, you'll still get back the same HTML response. Our server is very limited and is not what most web servers do. We want to customize our responses depending on the request and only send back the HTML file for a well-formed request to //. So basically what they're stating here is that currently we're bounded to this port, so localhost 7878, and anything that comes on 7878, regardless of the / after it, could be /something, /hello, /whatever, we're always going to send back the same data. However, typically in a web server, you go to an address, and if you go to the wrong address, even if you're on the right port, they're going to tell you you're on the wrong page. Things like that. We want to try to do that for our /. Make sure people are going to the root, the / and not anything else. So, validating the request and selectively responding. Right now, our web server will return the HTML in the file no matter what the client requested. Let's add functionality to check that the browser is requesting / before returning the HTML file and return an error if the browser requests anything else. For this, we need to modify handle connections as shown in listing 20.6. This new code checks the content of the request received against what we know a request for / looks like, and adds if and else blocks to treat requests differently. More or less what it seems like is that we're going to look at the get portion of the like the header stuff where it says whether it's a get or a post, and we're going to check to see if this is it's a get /. That's what my guess is. And let's read through this. We have a buffer, same buffer, get out the basic information. We hardcode our get here if the buffer starts with, so if the request starts with this line, which is bytes because of the B here, then we do this. So we're doing explicit check for the /. Probably not the greatest, but yeah, okay, it will work for this example. And then anything else, do something else here, which they don't even have something else written there, which is kind of awkward. We could write this. We'll just add something for this something else. So they replaced all of handle connections. And then for our something else, let's write our content as in, I don't know, let contents equal bad request. Let them know something, right? And that should work because content is here and it's just a string. So we're matching the format. We just don't have the HTML lovely stuff in it. But let's run it and verify. Localhost. Oh, it remembered this time. Hello from Rust. I could have just duplicated the tab, right? Yeah. /hi bad request. That's all we send them, just to let them know. So we can tell now that the else block was initiated. All right, let's get back to it. Turn this off. First, we hardcode the data corresponding to the / request into the get variable. Because we're reading raw bytes into the buffer, we transform get into a byte string by adding the B, and then you have the quotes, byte string syntax at the start of the content data. When we check whether buffer starts with the bytes in get, if it does, it means we received a well-formed request to / which is the success case we'll handle in the if block that returns the contents of our HTML file. If the buffer does not start with the bytes in get, it means we've received some other request. We'll add code to the else block in a moment to respond to all other requests. Which we already did that, but they probably have something a little bit better. Oh, they have 404. I see. That makes sense. Run this code now and request localhost 7878. You should get the HTML in hello.html. If you want to make another request, such as localhost port 7878 / something else, you'll get a connection error like those you saw when running the code in listing 20.1 and 20.2. We added something else in the else block, so we didn't get that, but yes, they're right. Now let's add the code in listing 20.7 to the else block to return a response with the status code 404, which signals that the content for the request was not found. We'll also return some HTML for a page to render in the browser, indicating the response to the user. And this is just the else block. We can read through it first. Status line, they do it properly. HTTP, they have the version, they have the status code, and then they have the phrase thingy. There's 0 headers and there's 0 body. Oh wait, no, there are contents. They have a 404 page, which I guess is down here. Okay, that's good to know. And they format this. They want the status line, this thing. And right after that, they want the contents here. And then they write that. So this makes sense. We can do this. Copy. Open this up. Put that here. Cargo format. Make it look pretty. And then we also need the 404 page, which we can read through it again. HTML5 document, HTML tag, English for the language, head. We set it to UTF-8. It still says hello. And we have oops, I'm sorry, I don't know what you're asking for in the body. So it's pretty straightforward as well. New file, 404.html. Cancel, paste, golden. So let's open this up again and let's run it. And we already saw the local host, a proper connection. So let's just go to something else. Let's go to hi / hi. Hey, that didn't work. What was the error? Panicked. Wait, why did it panic? Hold on. No such file directory. It didn't find 404.html. I see. Let's see if we can correct that. 404.html, because it's in source. I don't want it to be in source. Can I move it? Move source 404. And now it's worked since it's in the right location. Run. Bam. Oops. Sorry. I don't know what you're asking for. So this is what we wanted to see. All right, cool. With these changes, Run your server again, requesting localhost 7878. You should return the content of the hello.html and any other request like localhost 7878/foo should return the error HTML from 404.html, which we demonstrated. A touch of refactoring. At the moment, the if and else block have a lot of repetition. They're both reading files and writing the content of the file to the stream. The only difference are the status line and the file name. Let's make the code more concise by pulling out the differences into separate if and else lines that will assign the values of the status line and the file to variables. We can then use those variables unconditionally in the code to read the file and write the response. Listing 20-9 shows the resulting code after replacing the large if and else blocks. More or less, they realize that our if and else have a bunch of stuff in common that can be taken out. Sort of like a multiplication problem where you have like the same parts on both sides and kind of just move them out. Yeah, we're doing something like that. Factoring out. That's what it was called. Haven't been in school in a long time. All right, so what they did was they define, they're using a let to define status line and file name. And if the buffer starts with this thing, if the buffer starts with the get, which we already predefined, do this. And this is the file to find the HTML you want. Else, do this. And this is the file that you want to find the HTML. And then everything else stays the same, which is more or less cool. Let's just verify it works the same way. So this is everything right here. Here's the get. Yeah, that's it. That should be it. Cargo run. Localhost, that is there. /hi. /hi. And then we get this. So the refactor works just the same way. A little less code, a little cleaner. Approved. Now the if and else block only returns the appropriate values for the status line and file name in a tuple. We then use destructuring to assign these two values to status line and file name using a pattern in the let statement, as discussed in chapter 18. And what they're mentioning there is that this tuple thing is the destructuring. This is like returning two items, and we're placing this one there and placing this one there. That was discussed chapter 18. Meh. The previously duplicated code is now outside the if and else block and uses the status line and file name variables. This makes it easier to see the difference between the two cases, and it means that we have only one place to update the code if we want to change how the file reading and response writing work. The behavior of the code in listing 20-9 will be the same as that in listing 20-8, which we verified. And another thing that we're stating here is now when we look at this code and we want to figure out the difference between the first case and the second case, we now know that the only real difference is these two lines, whereas before we had tons of stuff in there, and then we also had to mentally filter out what was duplicated and what was not. That can be an awkward situation to be in. It's better just to be able to see it clearly, be like, oh, this is different from this, and everything else is used. Everything else between them is the same. Also, we now have a simple web server in approximately 40 lines of Rust code that responds to one request with a page of content and responds to all other requests with a 404 response. Currently, our server runs in a single thread, meaning it can only serve one request at a time. Let's examine how that can be a problem by simulating some slow requests. Then we'll fix it so our server can handle multiple requests at once. And that is the end of this video. If you like it, hit like, subscribe. Outside of that, see you next time. Peace.